It's a real pleasure to be here to talk about the research that I do, which is metallic alloy development for additive manufacturing, commonly known as 3D printing. My name is Yongho Sohn. I'm with the Department of Material Science and Engineering. So when people talk about additive manufacturing, or more commonly known as 3D printing, really the vision is to really manufacture anything, whether it's organic or inorganic, regardless of the application. And another important aspect is to manufacture where things are needed. It could be the use of the resources at those locations and so on and so forth. So these are some of the visionary kind of concepts for the additive manufacturing. But there is a gap in technology that we need to explore. And of course, that represents an opportunity in research. So in my line of work, basically, we are interested in developing a new or modified alloys that will actually take advantage of some of the thermodynamics or kinetics environment that is associated with additive manufacturing. And because of that, it really is an exciting time to be in this business to develop new advanced materials and design component with manufacturing sort of inherently built in. Some of these alloys that are listed here, it may not make sense a lot to you, but these are basically alloys that are available for additive manufacturing. Very small number, actually, because the alloys that are in commercial use right now, they were never intended actually for additive manufacturing process. So most of the alloys being examined, whether it's research or commercialization, or they're actually not designed for additive manufacturing process. For example, like the powder bed fusion that I'll talk about. So we are doing a lot of research and making of new and modified alloys specifically for additive manufacturing. And we're also mixing in a little bit of machine learning as well in terms of the design aspect. And our lab basically offers education and training through projects that are centered around additive manufacturing. We make real stuff, and there's a lot of apprenticeship that goes on in the lab, which I will talk about. So one of the key capability that we have in our laboratory is so-called the gas atomization. So basically, we are making the metal powders, and you can basically consider this as a sort of a toner for your printer. So we can mix in a variety of different elements, melt it, and pulverize it in high pressure gas environment to make the powders, which are basically the ingredients of the additive manufacturing in the current most process. So this is the melt, and we're actually pouring it for the powderization of the gas metal powders. The second, we have the printer in our laboratory. It's called laser powder bed fusion. You basically have a laser that is traversing, and it builds a three-dimensional object shown here that were printed in our laboratory using a variety of different manufacturing variables, which we also examine to optimize our manufacturing processing parameters. So our primary focus on research is basically the alloy design, and much of it is actually an experimental work coupled with some computational design using selected softwares, including machine learning, to get the properties and the durabilities that we want for a particular engineering applications. So these are our sort of sponsors or clients, including the commercial ones that are interested in designing a specific alloy for their commercial use as well. So we have worked in the past 5 years quite a bit with the U.S. Army and Naval Research and the nuclear folks from the U.S. DOE on lightweight structural alloys, such as aluminum alloys and the magnesium alloys that are used for a variety of different applications. And we had made quite a bit of successful stories for them, for their use in some of the engineering applications. Currently, we are actually working with U.S. Army on making some of the high-strength steels that are currently deemed not printable, and it doesn't show very good properties, for example, So we are trying to modify, for example, the commercially existing alloy compositions so that it will have that high strength, which is exhibited by this kind of curve behavior in terms of the stress that it can take in this high strength steel that the US Army would like to use. We're also designing a brand new kind of set of alloys. For example, this one is called high entropy alloys. And it has a simpler metallurgy, for example, than many of the very high temperature alloys that are used in gas turbine environment in current technology. So we're hoping that these kind of simpler actually alloy will replace some of the more commercially acceptable ones, such as Inconel 718, which is very commonly used gas turbine high temperature alloys. And we're trying to get to sort of compete with its properties using our sort of the new alloys that we're making specifically for this additive manufacturing process. To design a new composition and new alloys, we're actually shorthanded in terms of the actual manpower. So we are actually diving into a little bit of neural network so that we can actually correlate some composition dependent thermophysical properties to the actual parameters that we can use to optimize the 3D printing process. So far, it has worked okay within sort of an interpolation kind of machine learning environment. The extrapolation to a new alloy that we're designing remains a bit of a challenge still, but we're working on it to make that work. So to sort of summarize here, we are working on a variety of different materials, metallic alloys. Currently, we have done a lot of work on lightweight structural materials. Currently, we're working on more of the high strength and even some of the refractory elements for strength, temperature, radiation, and magnetic field resistance. So we have lots of students who are working in our lab. We were very used to the personal protection equipment even before the pandemic, I believe. And we try to have fun and do a little bit of science and engineering as well. And thank you very much for your attention. And I'll take any questions that you might have.
Thank you, Yongho. Maybe you have already answered this, but question from Amar about why can't the traditional alloys be used for additive manufacturing?
Very good question. Many of the alloys that are currently used, if you put it into an additive manufacturing process, because of the very rapid solidification that's involved, they tend to crack just because of the thermal residual stress. And if you have a lot of volatile elements in there, they also tend to evaporate, creating lots of porosities and so on and so forth. So it's a different type of processing, and the existing commercial alloys were never really intended to be processed under this extreme environment. So that's why there's an opportunity, a window to develop new alloys specifically for this type of processing or manufacturing technology.
For the sponsors, since you're making new materials, what are the deliverables usually? And it's a question from the dean.
Right. So usually it's the demonstrated printability of a particular composition. We don't get into a particular design or engineering component, although we do build some for the demonstrated purpose. So our deliverables will be the printability window of a particular composition that we had designed, which may satisfy their engineering requirement in terms of the properties.